Today's topic is name reduction reactions. So here in the name reduction reaction, I'll be dealing with certain reduction reactions in which there are certain name reactions. Okay, so like Pummer reactions and all. I'll let you know in the upcoming slide. So let's move on to the first reaction, that is your Wolf-Kishner reduction reaction. In this Wolf-Kishner reduction reaction, and the Wolf-Kishner reduction reaction is nothing but it is the excellent method for the reduction of the carbonyl compounds to N-methylene groups. Okay, so it can be either an aldehyde or the ketones in presence of the hydrazine. In first the hydrazone is formed, followed by the formation of your methylene groups, that is upon treatment with the base such as your KOH, potassium hydroxide, and upon treatment with the base is this hydrazone gets reduced by the formation of your methylene compounds. Okay, so in the mechanism, when an ketone is treated with the hydrazine, so what happens here, when the water molecule gets cleaved out from one of the NH2, okay, H2 from your hydrazine in, and the this NH2 is there, right? This H2 and O will get cleaved out to give you the hydrazone. Once the hydrazone is formed, upon treatment with the base such as your KOH, OH minus will go abstract the proton from NH2, and then this bond shifts and it will give you the negative charge upon the nitrogen atom. With the cleavage of the water molecule, that is your OH minus will combine with the H plus to go it as an water, that is your dehydration is taking place over here. Okay, leading to the formation of this intermediate. After the formation of this you can do the canonical forms, resonating structures can be obtained, right? So this negative charge shifts and it gives you the one new bond, that is a double bond is obtained over here. This double bond, one of the bonds shifts and it will give you the carbanion formation. Okay, once the carbanion is formed, then upon protonation, upon protonation, this carbanion will abstract the proton and after the abstraction of the proton you are gaining this adduct. Okay, once the formation of this compound, then what happens, there is the evolution of the nitrogen gas, and so this bond, nitrogen and hydrogen, one bond shifts over here, and then this bond will shift and it will generate you the second carbanion. Okay, first carbanion is formed by the removal of the water molecule, dehydration step, and the second carbanion is formed by the evolution of the nitrogen gas. Okay, and after the removal of the nitrogen and the carbanion again abstract the protons upon protonation and it will give you the methylene compounds. Alright, so this is your reaction and the mechanism. It is an important reaction and mechanism for the exam point of view. All of these reactions are very important. In the next slide, this is the Mcmurray reaction, wherein here the speciality of this reaction is in this reaction, and it involves the coupling reaction and it requires the metal such as your titanium will be required as your metal. Titanium should be in the elemental form. Okay, so this titanium will be used as the metal source for the electrons. It will give the electrons, then only there will be the generation or coupling will takes place, and there will be formation of the two bonds between the aromatic compounds. Okay, cyclohexanes. So here what happens here is the reaction will involve, in the first step the diols are formed, 1,2 diols are formed which is symmetrically substituted, and in the next step the diols will give you the alkenes. Okay, this diols will give you the alkene upon treatment with the titanium. Okay, further treatment with the titanium will give you this alkene. So let's move on to this reaction. That process is known as your Mcmurray reaction. So what you are going to say is, what is your Mcmurray reaction? And so titanium will react with the first when the ketone is treated with the titanium chloride, trichloride, and titanium will act as a metal, it will give you the electrons. Once in the presence of the reducing agent, first diols are obtained, and after the formation of your 1,2 diols, then upon treatment with the again titanium, then the alkenes are formed. The phenomena is known as your Mcmurray reaction. Okay, to give an alkenes, that reaction is known as your Mcmurray reactions. So you can go through here, like we are taking the cyclohexanone. Okay, when the cyclohexanone is treated with the titanium chloride, trichloride, and upon treatment with the reducing agent such as your LaH, lithium aluminum hydride, what happens here is, here you are using two molecules. Okay, here you are using two molecules of your cyclohexanone and then when you are treating it with the two molecules of cyclohexanone, then you are resulting in the 1,2 diols. Okay, after the formation of 1,2 diols, this can be observed only at the lower temperature. If the reaction will takes place, if the diols have to be formed, you have to maintain the temperature at the lower condition, and then only the diols are formed. Then again upon treatment with the titanium, these alkenes will be obtained. That is your coupling reaction, homocoupling reaction will takes place. In the mechanism part, next slide, I'll show you the mechanism. So here in the first, what happens here is titanium in the zero state. Okay, in the zero state, which will be the source of the electrons in the reaction, which will produce during the reaction by reacting it with the titanium chloride salt. Okay, and again with the reducing agents such as your LaH, that is your lithium aluminum hydride, and the titanium will act as a single electron transfer. So here is the mechanism. We are taking the two molecules of your cyclohexanone and once the homolytic cleavage will takes place is upon treatment with the metal, single electron transfer, homolytic fission, and then this bond breaks, it will give you the radicals, right? So there is one radical over here and one more radical in the oxygen atom. Meanwhile, you have to take it for the one more also, like it is 2, right? So two molecules of that one if you will take, and the titanium will go and bind in the middle. It will form one complex, and once it will form that one, and then this radicals will combine, the one radical carbon radical, free radical will combine with the one more carbon radical of your cyclohexane, and it will make you one bond. Okay, so after the formation of one bond over here, the titanium then proceeds to the deoxygenate. It will deoxygenate, that means deoxygenation will takes place is for the formation of your diols. Okay, so here the titanium will cleave out by giving you the hydrogens. Okay, hydrogen will come and bind over here. In the next steps, you have to see here whatever see here the titanium and then proceeds to the deoxygenate a diol by binding the diols to the surface of the titanium zero particles. So here what happens, this is your surface titanium zero metal. Okay, titanium metal is there. Here to that they are binding. Once it will bind, then the diols will be formed. Okay, so after the formation of the diols, what happens here is the titanium will take this oxygen atoms along with them and it will give you the alkene bond formation. Okay, one bond is already over here. So when this will break, homolytic cleavage, and this again will when it breaks, what happens here, this will cleave out, and then O radical and then O radical will cleave out. Okay, so again when it is undergoing with the treatment with the titanium, it will give you electrons, single electrons, right? So it will make you the double bond over here. Here also double bond, here also double bond. So this radical, whatever the present radical will be there, if I have to show you, it will break it over here and again it will break it over here. So what happens here, this will give you 1 electron, right? So when it goes it as the O radical and here also O radical, this will give you 1 electron and 1 electron over here. So it will make it as a double bond, okay? And here also it will make it as a double bond. So here what you can see, double bond and double bond which is present over here, and here whatever the radical which is present over here and here, that both the radicals will combine and it will give you 1 bond, okay? That is your alkene bond is formed in between the 2 rings, okay? That is your coupling reaction, alright? Slide. I hope you understood this mechanism. That is your Pummer reaction. And so this is the rearrangement reaction, Pummer rearrangement reaction, and it is a kind of a reaction wherein in the alkyl sulfoxide is treated in presence of your acetic anhydride and or the elemental sulfur. Okay, in this reaction sulfur will get reduced to while adjacent carbon is oxidized. So here this is getting reduced and this is getting oxidized, alright? And so remember, in the reaction in general what you are writing is, when an alkyl sulfoxide is treated with the acid in presence of your acetic anhydride and an alpha acyloxythioether is obtained, that reaction is known as your Pummer reaction. How this will happen, I'll show you in the mechanism part, okay? So this is your mechanism over here. We are taking the alkyl sulfoxide. The first thing is, what you have to do is, you have to show the resonance over here. That is like keto-enol form. Okay, so here this bond will shift and it will gain you the O minus. The oxygen will withdraw the electron towards itself. So it will gain a negative charge and sulfur will gain a positive charge. Okay. So once this is obtained, to activate this atom we are doing this reaction, okay, to make it stabilize so that we can attack to the acetic anhydride and we can get easily our product. Alright, so once we are getting the O minus, as there is the attack of the negative charge of the oxygen atom to the carbonyl carbon of your acetic anhydride, okay. Once the O minus will go and attack to the carbonyl carbon which is electrophilic in nature, then there is a cleavage of this acetate ion, okay. CH3CO minus will get cleaved out, that is your this acetate ion gets cleaved out, alright, and you will lead into the formation of this adduct, okay. And after the formation of this adduct, again the acetate ion, the O minus will go abstract the proton, okay. Once it will abstract the proton, this bond shifts and it will make it as a double bond, and meanwhile there is a cleavage of another acetate ion over here, okay. This gets cleaved out. So once this is getting cleaved out, you are resulting in the acetate ion cleavage over here, okay, this one. And then after that what happens here, you are gaining a double bond and you will have the E positive charge, right? The sulfur will gain a positive charge, and after the formation of the positive charge upon the sulfur atom, the one more acetate ion which is cleaved out, so that will this whatever is there, that will cleave out as acetic acid, okay. And then this O minus will again go and attack to the alkene, and meanwhile this bond will neutralize the positive charge of your sulfur and you will result in the alpha acyloxy thioether compound, alright. This is all about your mechanism part, okay. Next slide. That is your willgerdot reaction. So here the mechanism is like 2 pages. It will need one mechanism because 2 scientists have discovered this reaction. So so first willgerdot has done the reaction, and what is willgerdot reaction is, it is an organic reaction which is converting the aryl ketone, that is this aryl ketones, into the corresponding amide, okay, by reaction with the ammonium polysulfide, alright. Here we are taking the ammonium polysulfide groups in the aqueous medium, then you are resulting in 2 moieties, 2 product formation. And then the Kindler, one more scientist, he came with the modification with the more convenient way. That is, it became with the willgerdot and the Kindler. Both of the scientists combined that reaction and it has named it as the willgerdot-Kindler reaction. Okay, that he said that let us see with the elemental sulfur. Here we are taking the polysulfide group. Okay, so let's test with the elemental sulfur. So when he said that when they did with that in the presence of the morpholin as the amine compound, when they took the elemental sulfur as well as the morpholin, they resulted in two product formation. Okay, so that mechanism only we are going to study over here. First, initially we will get the thioacetamide as our product, and again upon hydrolysis which can again be hydrolyzed to the amide formation. Okay, so here is the mechanism. First I will show you the reaction of the willgerdot-Kindler reaction. So this is the aryl ketone. When this is the methylene group CH2 0 to 5. That is any number of your methylene groups can be attached over here. Okay, n number of methylene groups. So he has taken the aryl ketones and he has treated it with the tosyl hydroxide and the elemental sulfur. This is your morpholin. The morpholin that is your amine compound, and upon heating you will get the thioacetamide formation. Again upon hydrolysis you will get back your amides. Okay, this amides formation, this carbonyl group will be present. Upon hydrolysis this S group will go and you will get back your oxygen atom over here. And then let's see with the mechanism. Aryl ketone we are taking and morpholin, and upon treatment with the TSOH, that is your tosyl hydroxide. In the first step, the oxygen which is present in the aryl ketones, this lone pair of electron will go and attack to the hydrogen. It will abstract the proton. Meanwhile, there is a cleavage of your tosyl group, that is your OTS will act as a good living group over here. Okay, and after the cleavage of the tosyl group, this oxygen will gain a positive charge because it is having a 3 bonds. One is with the hydrogen and the double bonds is present between the carbon. Alright, right? So after the formation of the 3 bonds, it will gain a positive charge. And the next thing is conjugation, that is the resonating canonical form. So this bond shifts, it will neutralize the positive charge of the oxygen atom. There is a gain of the positive charge in the carbon, that is your carbonium ion is formed. Okay, carbocation is formed. Once the carbocation is formed, then the attack of your morpholin compound. That is, the morpholin contains the nitrogen atom which is having a lone pair of electron, that will go and attack to your carbocations. And after the attacking of this, you will get back this structure. Okay, again the second molecule of your morpholin will go and abstract the proton and here what happens, once it will go and attack, the nitrogen will gain a positive charge over here because it is having the 4 bonds, 1, 2 and then 3, 4. Okay, and it will have a positive charge. And the second morpholin compound, nitrogen which is having a lone pair of electron, will go abstract the proton and this bond will neutralize the positive charge. Okay, once it will neutralize the positive charge, you are getting this adduct formation. Okay, after the formation of this structure, again there is the attack of your morpholinium ion, that is your whatever is cleaved over here, that one. Okay, the O oxygen atom which is having a lone pair of electron will again go abstract a proton and meanwhile there is a cleavage of there is a neutralization of this bond, and this bond will neutralize the positive charge of your nitrogen atom. Okay, and it will cleave out and then you will gain the OH2 plus. Okay, here you will gain the OH2 plus, and then there is an intramolecular reaction. What happens here is the nitrogen within a molecule which is having a lone pair of electron will shift, make it as a double bond, and meanwhile there is a cleavage of your water molecule. Okay, when the water molecule gets cleaved out, So here the water molecule gets cleaved out. Okay. Okay. So here the water molecule gets cleaved out, and then there is a formation of this structure. All right. And once this structure is formed, then what happens here is, once this structure is formed, one second, once this structure is formed, you have to open this methylene compound. Okay. You are opening the methyl, that is your CH3, one of the hydrogen atom, you are opening it up, and then this OH2 molecule, water molecule, which is having again lone pair of electron, will go attack your H group and then H group of your methyl, and meanwhile there is a shifting of this bond towards this side, right? And this bond will neutralize the positive charge of your nitrogen atom, and then you are getting this structure. Again, upon treatment with the sulfur, what happens here upon treatment with the sulfur, this atom, okay, so here the carbon ion is formed, and then after this, one of the hydrogen will cleave out and it will generate the carbon ion and it will attack the sulfur. Then you will get the SH. Okay. After the formation of your thioacetamide, right, thiols formation, SH, then there is again attack of your OH2 molecule, that is your water molecule. Well, again the lone pair of electron will go attack your hydrogen atom, and then this bond will shift, it will generate the negative charge towards your sulfur atom. Okay. And so then once this sulfide ion is obtained, then again there is the attack of the H3O plus. Okay. So this H3O plus, first this negative charge of your sulfur atom will go, it will make it as a double bond. Meanwhile this alkene bond is there, right? That will go abstract the proton, and there is a cleavage of your water molecule. Alright, right? And then you are resulting in this structure, and there is a formation of your aziridine structures over here, that is the intramolecular reaction, and the nitrogen which is having a lone pair of electron will again go attack to the carbon atom over here. Meanwhile there is a shifting of your alkene bond, it will get you as a negative charge towards your sulfur atom, and again that sulfur sulfide S minus will abstract the proton, and there is a cleavage of your water molecule over here. Okay, and you will lead to the formation of your SH, thiols formation. And then after the formation of this compound, the hydrogen, that is your CH, it will open it up, and this this bond shifts over here, and meanwhile the bond which is present over here, carbon and the nitrogen bond, will neutralize the positive charge of your nitrogen atom. Alright, making you it as a double bond over here. And after the formation of double bond, the thiol group SH, the sulfur atom which is having a lone pair of electron, will go make it as a double bond. The alkene bond will again goes abstracts the proton. Meanwhile there is a cleavage of your water molecule, resulting you in this structure. And after the formation of this, there is again attack of the water molecule. Well, the oxygen which is having a lone pair of electron will go attack to the carbon atom, and there is a neutralization of the positive charge of your sulfur atom. Okay, and then you will gain this structure, and again there is the attack of the water. Alright, please don't get confused with this mechanism. So OH2, that is the lone pair of electron, will again abstract the proton. This bond will neutralize the positive charge. Meanwhile there is the attack of the lone pair of electrons of the sulfur atom to the H3O plus hydronium ion. One of the H it will attack, and there is a cleavage of your water molecule. Okay, and then you will result in this structure. The OH, the bond which is present between the OH, this bond shifts, it will make it as a double bond, and there is a cleavage of your H2S. Okay, there is a cleavage of your H2S, resulting you in this formation of your this product, final product. This can also be written it as like this form. Alright, this is all about your willgerdot reaction. Alright. Okay, then on to the Kore-bakshi-shibata reaction. This is a reaction wherein the reduction of the achiral ketones to the chiral alcohols, as it is an enantioselective reaction which gives the high yield enantioselectively, and it is using as the alkoxy amine borane complexes. Okay, that is your oxazoborolidine complex. That is one of your alkoxy amine borane complex. Remember this, it is very important reaction. And so here what happens in this reaction is, so enantioselective reduction of the ketones using the oxazoborolidine in reagent, and will give you the chiral alcohols. This phenomena of this reaction is known as your Kore-bakshi-shibata reaction, which is also known as CBS reduction reaction. Okay, CBS means Kore-bakshi-shibata reaction. Alright, then moving on to mechanism. This mechanism is very easy. So just you have to remember this oxazoborolidine reagent. Okay, so this reagent, if you will remember, then the reaction will be very easy for you. So this reagent can oxazoborolidine reagent, this can also be written it as in this form. Usually in the mechanism part we'll use this type of reagent. Okay, we'll not use this one. So what happens here is, the lone pair of electrons of this nitrogen atom will will go and attack to the boron. Okay, BH3. Okay, once it will go and attack to the BH3 ligand, then there is a formation of this complex moiety. Okay, after the formation of this complex, then there is the attack of your ketones. Okay, the ketone will have one of the alkyl substituent with the smaller atom, and the another will be the larger. Okay, smaller in the sense you can take it as your it can be either an aldehydes or an ketone. So you can take it as a H over here, hydrogen, which is for the smallest substituents, and here C6H5 phenyl group, which is your bulky. Okay, so that one you can take it as for an example. Then what happens here, the oxygen which is having lone pair of electron will go attack to the boron atom. Once it will go and attack to the boron atom, then what happens, there is a formation of this structure. Alright, and after the formation of this structure, first when it goes and attacks, it first makes one bond, complex bond. Don't show the attack over here itself. Okay, don't show the attack over here itself. Don't show this attack. First there is a complex, you can see over here, right? So first what happens, first the hydrogen is forming one of your you're coordinating the hydrogen with the carbonyl carbon of your ketone group. Okay, then there is the attack of your oxygen atom, that is your oxygen which is having lone pair of electron will go and attack to the boron atom. Okay, once it will go and attack, then what happens, it will gain the negative, boron will gain a negative charge over here, because it is since it is forming one of the coordination with the carbon atom. Okay, and then after the attack of the carbonyl compound, and then resulting in this structure. Okay, then after the formation of this structure, what happens here is, this bond shifts and it will gain you as the first it will gain you as a negative charge. Okay, first what happens here is, this bond will shift and make it as a bond over here between the oxygen and the boron, and that is OBH2 will be obtained in, and meanwhile there is a cleavage of this whole moiety. Okay, this whole moiety gets cleaved out, and then this will go it as a side product over here, and you will result in the borate complex. Okay, borate formation will takes place over here, or after the formation of the borate over here, then the acid workup will takes place. Okay, once the acid workup will takes place upon hydrolyzation, then it is hydrolyzed, and then upon acid workup, what happens here is this OBH2, this BH2 will get cleaved out, and it will give you the H atom to the oxygen atom. O minus will abstract the proton, then will result in the chiral alcohols. Okay. Then Tishchenko reaction. Moving on to Tishchenko reaction, here what happens, there is a formation of an ester from the aldehydes by the oxidation reduction reaction, that is your redox reaction process, in the presence of your aluminium alkoxide reaction. Moving on to that reaction, here are certain points. So that reaction is known as your the aldehydes reaction. Whatever the aldehydes you are taking, it should have the alpha hydrogen. With or without the alpha hydrogen, the aldehyde should be there, and that can undergo this reaction. Aldehydes can only undergo this reaction, and one of the aldehydes will be oxidized to give the acid, and another molecule will reduce to give you the alcohol. Okay, that acid and alcohol together will give you the ester. So moving on to the reaction, and two molecules of an aldehyde is treated with the aluminium alkoxide and to form an ester. An ester is formed. That reaction is known as Tishchenko reaction. So moving on to mechanism part, when an aldehyde is taken and it is treated with the aluminium alkoxide, at first there is a formation of one bond between the oxygen and the aluminium. Okay, the oxygen lone pair of electron will go and attack to the metal, that is your aluminium. Then what happens, and there is a formation of this ion, that is your adduct formation intermediate, and oxygen will gain a positive charge and aluminium will gain a negative charge. Alright, and after the formation of that, there is again attack. So here you can write the resonating structure of it. This bond, when it shifts over here, or what happened, there is a neutralization of the positive charge with the gaining of your carbocation in the carbon atom. Okay, so here you are not focusing on this structure, whereas this is your stable moiety, so you will focus in this to get you as this adduct, this product, sorry. And then there is attack of your second aldehyde, and the oxygen will go, lone pair of electron will go attack to the carbonyl carbon, which is electrophilic in nature. Meanwhile, there is a neutralization of the positive charge of your oxygen atom. Okay, and after the formation of this adduct, then what happens here is there should be a neutralization, right? It can be reversibly, this reaction will take place. So what happens, this bond will neutralize the positive charge of your oxygen atom, and then there is a generation of your carbocation and after the generation of the carbocation on the oxygen and the aluminium bond. Okay, this bond will come back, it will make it as a double bond. Meanwhile, what happens here is there is the attack of rearrangement, hydride shift, which is taking place over here. This hydride is shifting towards your carbocation. Okay, once there is a hydride transfer, there is a cleavage of your aluminium alkoxide. Okay, after the cleavage of your aluminium alkoxide, you are resulting in the ester molecule. Alright. If you have thank you. If you have any doubts, you can ask me in the comment box. Like and subscribe my channel.